something is in this, we call as a linear system. It has a transfer function or impulse response, ht comma tau, and it's a Fourier series or in transformation h omega in frequency domain. The input for the linear system is xt, where xt is a wide sense stationary random process. Output is called yt, and it is also a wide sense stationary random process. Okay, so how we are getting yt? Yt is xt. Some transformation is applied on xt, where t is operator here. T is a transformation operator. T is transformation operator, and input and output are related by convolutional. The output yt is xt convolved star is a convolution ht, or this can be also written as ht star xt. This convolution, this operation is called convolutional, and this is in time domain. Convolution is in time domain because you have represented them in time, xt and yt and ht. Okay, so the convolutional integral is given as integration from minus infinity to plus infinity xu h t comma u du. Okay, now what is the time invariant? Can someone tell me what is time invariant? Anyone? Time invariant system. Anyone? No one is telling. Time invariant system means the response does not depend on time. It is independent of time. That means ht comma u and ht minus u. Ht minus u is a delayed h. Ht comma u, it is somewhere at some time. Ht t minus u, it is delayed and it is some time. Both are different times. Even though they are at different times, the response is same. Okay, so let us substitute this ht comma u in the integral. We get yt is equals to, we are going to get two formulas, integration from minus infinity to plus infinity xu h t minus u du, or you can also use integral from minus infinity to plus infinity hu x t minus u du. Okay, so these two are convolutional integral. Convolutional integration. Okay, so any doubt up to this? The star represents, let me write here, star represent convolutional. Star represent convolution. Are you with me? Now,
రండి ఇప్పుడు వాడిని స్పైడర్ మ్యాన్ కానీ తన్నిందా జుయా జుయ్
number 81. Mute yourself. Is Tarun is your classmate? Anyone?
Yes, sir.
Why he is joining using Gmail. రైట్. మిమ్మల్ని మ్యూట్ చేసిన కూర్చోవాలండి నేను.
ఇది చూసినావా ఇది
ఏ తరుణ్, roll number 81. So a linear system is said to be time invariant if impulse response, what is ht comma u? We call this as a impulse response. So if the impulse response is independent of time, then the linear system is said to be time invariant. Let me write that.
సార్ పిటిఎస్పి అంటే ఏంటి సార్?
What? Come again?
Remove him, sir. He's from outside.
Tarun is outside from?
నో
Yes,
సార్,
sir.
ఎంవిఎస్ఆర్ కాలేజ్ సార్ నాది.
Then someone is asking what is PTSP. Who's that?
ఎస్ సార్.
ఎవరు అడిగేది? Someone has asked, who's that? ఈ టాపిక్ తో PTSP సబ్జెక్ట్ అయిపోద్ది. Now you are asking what is PTSP. Okay. So a linear system is said to be time invariant. Time invariant if its impulse response h t comma u does not change with time. Okay, this is about linear system and that too time invariant system. So how to find the mean of yt? Can someone tell me?
Expectation of IP.
Yeah. So all of you find out, apply expectation on yt formula. All of you apply expectation on this yt formula and tell me what you get. You apply formula on this second formula. You apply expectation on this and tell me what you get.
Cross correlation.
You just apply expectation on yt in that formula and tell me what you get. What are you getting? What are you getting? How outside student entered into the class? How he knows this class ID? Anyone? Okay, I'm going to use this second one formula yt equal to integral hu x t minus u du. So what we have to do? We have to apply expectation on yt. So expectation of integral from minus infinity to plus infinity hu x t minus u du. Now we have to enter this expectation operator into the inside the integration. So inside the integration h is there, x is there. So in these two, to which one we have to apply expectation operator?
Random variable.
Random variable. Which is random variable?
H of u and x of
HU is not random variable. Already in the diagram I have mentioned xt is a Whitson stationary random process, yt is a Whitson stationary random process. These two are only random variables and random processes. HTU is not a random variable. Here we are not considering that as a random variable. So expectation operator we should apply on xt minus u du. For a Whitson stationary random process, what is the mean? Is mean constant or varies?
constant.
This expectation of xt minus u, let us say as a m, and this is always constant. So expectation of yt is equals to integral from minus infinity to plus infinity hu m du. Anyway, m is constant. We can take it outside. So u is m integration from minus infinity to plus infinity hu du. This is the mean of output yt of a linear system. And if you clearly observe, m is constant and integration is also constant. Both are constant. Am I right? M is a constant. And integration HUD is also constant. So finally, expectation of YT is constant. Okay. Next, let us find out autocorrelation function. Can anyone tell me why we are finding the mean and autocorrelation function? Anyone guess why we are finding mean and autocorrelation function?
Wide sense stationary.
Yes, I have given xt as an input and I am saying that it is a wide sense stationary random process. This xt is subjected to some transformation. It is going under some transformation. So the output yt may be wide sense stationary, may not be wide sense stationary. So we have to find out its autocorrelation function. Okay, so for that purpose we need to find out autocorrelation function. So r double yt or r double y tau is equals to expectation of yt y t plus tau. Right. So let us apply the yt formula in autocorrelation function. So expectation of yt is integration from minus infinity to plus infinity h u1 x t minus u1 du1. I'm taking a dummy variable u1. Second integration from minus infinity to plus infinity h u2 x t plus tau minus u2 du2. Okay, now the expectation is applied on the random process x t minus u1 and x t plus tau minus u2. So let us apply that integration from minus infinity to plus infinity. Integration from minus infinity to plus infinity. Expectation of h not h x t minus u1 x t plus tau minus u2 h u1 h u2 du1 du2. Okay, but can someone tell me what is the expectation of x t minus u1 x t plus tau minus u2? Can someone tell me what is this? Is it autocorrelation function or something different? We are applying expectation on x t minus u1 x t plus tau minus u2. So this is the correlation and we are applying this expectation on 2x. So it is a autocorrelation function. What is the time delay? Can someone tell me what is the time delay between these two? Tau plus u1 minus u2. How you find out time delay?
Difference.
Difference. T plus tau minus u2 minus t minus u1. This t gets cancelled. Then we get tau minus of minus u1 plus u1 minus u2. Okay. So let us substitute this in r double y tau. Then it gives us integral from minus infinity to plus infinity. Integral from minus infinity to plus infinity. R double x tau plus u1 minus u2 h u1 h u2 du1 du2. So this is the formula of autocorrelation function of yt. Okay. Similarly, let us find out cross correlation. R xy tau and r yx tau. Correlation అంటే xy కావచ్చు లేదా yx కావచ్చు. Okay, so let us find out the first one. rxy tau. So what is rxy tau formula? Expectation of xt y t plus tau. Okay, so expectation of xt itself is xt, yt plus tau is integral from minus infinity to plus infinity h u x t plus tau minus u du. So integration from minus infinity to plus infinity, expectation of xt x t plus tau minus u and hu du. Can someone tell me what is this integration? What is this expectation? What is this? It is r double x. What is the time delay? Tau minus u. So the correlation rxy cross correlation is given as integration from minus infinity to plus infinity hu r double x tau minus u du. It is same as a convolution formula. It is a convolution integration. It's a convolution formula. So we can write it as r double x tau star h u. So this is the cross correlation formula. Second one, ryx tau. So I'm giving you this as a homework. You will get as the integration from minus infinity to plus infinity. You get h minus u r double x tau minus u du. This is the integration, convolution integration. You will get r double x tau convolved with h minus u. This you will get. Let us also find out mean square value of yt. Mean square value of yt. What is the formula for this? Anyone? What is the mean square value of yt? Expectation of?
Y square.
Can anyone? Yeah, y square. Very good. So I'm going to write this as expectation of yt times yt. And let us apply the yt formula. Integration from minus infinity to plus infinity. Let us take dummy variable u1 x t minus u1 du1. For the second one, I am going to take another dummy variable h u2 x t minus u2 du2. So simply we have to apply the expectation operator on this x t minus u1 x t minus u2 and the remaining is hu1 hu2 du1 du2. Right. Now can someone tell me what is this? What is this?
R x of minus u2 plus u.
u1 minus u2. Okay. So the expectation of y square t means mean square value is integral from minus infinity to plus infinity, integral from minus infinity to plus infinity r double x u1 minus u2 h u1 h u2 du1 du2. These are all used when you are going to apply Fourier transform on this, and you'll get the post vector densities. Understand? These are required whenever you are going to find out the post vector density. Post vector density and you have to apply the Fourier transform on the inputs. What is the input? Xt and yt for the Fourier transform. So any doubts in this? So far, whatever we have derived means mean of yt, mean square value of yt, autocorrelation function of yt, cross correlation function xy, cross correlation function yx. These are all time domain parameters. These are all time domain parameters. Next, we have to apply Fourier transform on this, and we'll get the post vector density. That is the main topic in the fifth unit. Okay, so far we have not touched that. We will see that in the next class. Sierra, are you there? Sierra? సిఆర్ ఇద్దరు ఉంటారు కదా సిఆర్లు.
Sir,
Yeah, tell me